Am I audible?
Yes, sir.
Let's wait for another 1 or 2 minutes. Okay, let's get started. I think recording is in progress, right? Okay. So in the last class, we built our Flipkart project, right? Say this is how the project folder structure looks like. We all know this. Flipkart, under Flipkart, we have src main test. And then here you have pom.xml file. This is where we write configurations, correct? So briefly, src main java group id. Assume that here you have calculator.java. Here you'll be having calculator test.java, right? The moment we execute this yaml install command, what happens? Can somebody tell me what happens when you execute yaml install command? It first executes a target called compile target, right? During this phase, what will happen? It will compile the main code. Then it will go to test compile. You have to remember these steps, okay? Then it will execute test compile target. During this phase, what will happen? Maven compiles testing code. Then it will go to test. So during test phase, what it will do? It would have already compiled testing code, right? By here. So it will execute the compiled code and then it will generate the test cases. So you'll come to know how many test cases are passed, how many test cases are failed. Then it will go to package. Here it will create either jar or var file. So if you had given jar here, it will create the jar. If you had given var, it will create a var file. Then what happens? It will copy, then it will go to install phase. During this phase, what will happen? It will copy created jar or var file to .m2 repository. That's what happens, correct? And you also know pom.xml file structure. So I'm going to the same previous project. Go to source. So first step is what? How do you build the project? We first clone it. Then we just execute yaml install command. Correct. What this will do? It will create target folder. It will get a target folder, and then it will store class files, main class files, test class files, reports, jar or var file, everything in that target. So it's executing all those steps here. So here we have target. So main class files are here. Testing class files are here. Reports are here. In this project, we are creating a jar. So you can see jar there. And in pom.xml file, pom.xml file always starts with the project, ends with the project. Pom.xml file should have GAV tags, group ID, artifact ID, packaging. Packaging is the tag where you define whether it is a jar or var file. And here you see some code snippet here, right? What is this? I'm trying to explain this to you today. So this is mostly, this is purely related to the development. Okay, everybody, this is related to developers. Try to understand the concept. We don't have to, write this. We don't have to write this code. Developers write. But as a DevOps engineer, if we can understand that, it is kind of added advantage. If we can understand that code snippet, it is added advantage. So that brings a new concept called dependencies. What that? Dependencies. So that's a topic name, okay? Dependencies. So for example, we all know this. Can we write complete Flipkart application code in one .java file? No, right? Can write something like this, flipkart.java, everything in one .java file? No. It will become, you cannot manage it basically, right? It will become huge millions of lines of code, right? And GBs in size. So developers don't write complete application or software code in one .java file. No. Instead, what do? They split the code across multiple .java files. Split the code. They write the code in different .java files. For example, assume that developer is, writing code for calculator application. Okay, so this is how developer writes the code first. A is equal to 10. Developer is taking the value from the user, assume. B is equal to 20. And then this guy is writing add A comma B. If you see, this is a function call. This is a function call. You are calling add, and then you're passing A10, B20, correct? But do you have logic for adding these two numbers here? Do you have logic here in this particular file? How do you add two numbers? There is a logic, right? C is equal to A plus B. You have to write something like this, but developer is not writing logic here. Developer just says calling a function add A comma B. Okay. And then this addition functionality, additional logic, he is writing here in some other file. That's how they write the code in multiple .java files. See here what this says. He is defining a function. Okay, public int add a comma b, c is equal to a plus b, right? That this is the actual logic which adds two numbers, return c. So developer is writing calculator functionality in two .java files. How it works? A is equal to 10, b is equal to 20, add a comma b. The moment you say add a comma b, it will call this function add. It will come here by passing 10, 20. So a value becomes 10, b value becomes 20. With a10, b20, it will come here. a10, b20, 10 plus 20, 30. And then it is returning 30. So if anybody calls this particular function, passing two numbers, this particular function is actually adding two numbers and then it is returning the result. Correct? So what is it returning? 30. So developer is displaying, okay, this, what is the value of add a comma b? 30, right? It received 30, correct? You're calling something, you're receiving something. What you have received? 30. So 30 is assigned to result variable. And this guy says display result 30. So 30 will be displayed on the screen. See how it is working? So taking two numbers, you are calling, right, a function. This is where you are adding, and then it is getting the result, right? And then display result 30. So that's how developers develop different feature, writing the code in different files. So basically you'll be having multiple .java files. And now you know, right, how one .java file is calling another .java, right? The link. When you have 10,000s of .java files, this is how Java code interacts. Okay. That's about the developer side. That is about developer side. Developers write the code. They decide the code, right? See, if developer wants, developer can write, the logic here itself in one .java file itself. But if you write everything in one .java, it will become, huge, right? And there is something called code reusability in software. Code reusability. Since you have this add function in a separate file, you know what? Anybody in your organization, this guy is working on login, this is working on card functionality, this guy is working on payment gateway. For example, these guys also writing some Java code, these developers, they want additional functionality. They don't need to write this code again and again, right? Harry has already written the code. So they'll just, when they want add, they'll just send some numbers, some values. So this will take values and then this will get the result. So you people are calling the same code reusability. So that will save a lot of time and things like that. There are a lot of other reasons why developers write the code in different files. That's about the development. That's about developers, right? We are not developers. We are DevOps engineers. What is our job? Compilation, correct? So how do you compile, these two files? In this case, I can say calculator.java has a dependency on addition.java, isn't it? Without addition.java, can you execute calculator.java? No. Correct? Because add a comma b, but where is the add function? You need to have a logic, right? You don't have a logic. It has to go and then call the code, which is in another .java file. So I say without addition.java, this will not work. So I can say calculator.java has a dependency on addition.java. Remember. So when you have these kind of dependencies in your code, right? Compilation, you need to follow something, right? If you want to compile, those .java files. Let us first see how you manually compile. How you compile this code manually first. Let's see the manual compilation. How do you compile a .java file? What is that command we use manually? How do you compile Java code? What is that command we use?
npm install.
That's for everything.
Java C.
I want to only compile the code. Yes, Java C. Java C. And then you say calculator.java, correct? Okay. So what this will do, this is a compiler, right? This will go and then check this syntax of this line. Next, it will go here. Next, it will go here. Okay. Now you're calling a function, right? What is the compiler's job? This guy will go and then, check the syntax rules and things like that. So it will come here. Compiler will come here. Okay. You are calling a function. So compiler will say, check this. You're calling a function. Show me the proof. Do you have that function written? Where is that? I don't see that function in this particular file. So since this particular function is not developed in this particular .java file, it will throw an error saying, I don't know what is this add. It's a compilation error. It will throw an error. Because see, without checking the proof, for example, if compiler gives you dot class, calculator dot class, for example, right? When you execute the class file, it has to interact with addition dot class, correct? Right? So dot Java, this is how it calls it. When you execute the class file, same thing happens right here. So at the time of execution, you will get the error if this is not there. So it says at the time of executing the code, right? Instead of throwing the error at the time of executing the code, I want to check now itself, because who executes the code? Your customer, right? We don't want your customer to, your software or application should work for your customer, right? So what it does is it will check, okay, give me the proof. Otherwise, if you don't give the proof, it will throw the compilation error. So if you have dependencies like this, okay, when you are compiling a particular file, you will get compiler requires a proof. If you don't give the proof, it will throw compilation error. But we know, right? We know the developer know. We are in this developer know that yes, function is there. So you have to give the proof to this Java C. So how do you give the proof? Hello Java C, please compile calculator.java. I know that I only wrote the code, right? I know that there is a function call, and I know that you will ask for the proof, okay? And that function is already written here. Go and check there. So you have to give -cp class path, okay? -cp. You have to give this something like this, addition dot Java. Now what will happen here? Hello Java C, please compile calculator.java. If you need any proof, go and then check in this particular path, class path, addition.java. So now compiler checks for the proof and then it will give you calculator.class. So when you have dependencies like this is how you compile the files. We can call this as what? Dependency. What is this? Dependency. Correct. But we should not give .java here. Instead of .java, we have to give .class. Okay. That means what? You have to first compile addition.java, then only you can compile calculator.java. Understand this? So this is called as a dependency. That means what? In order to compile calculator.java, I need another file. So I need a dependency. This works perfectly fine. Clear? Now, what if this particular calculator.java is calling functions from other .java files? You have to add all these class files here, right? File a.class, b.class, c.class, and so on. So you may have to add, right, say hundreds of dependencies sometimes, and it is inconvenient now. If it is one class file, I can give something like this. Okay. If you need multiple class files, then passing hundreds of class files becomes very difficult. That says, and what we do, guess? Guess what we do? Instead of class file, we give jar file. For example, jar file name is, okay, addition.jar. Addition.jar. And jar contains what? Multiple class files, right? Jar is collection of class files. So, hello Java C, please compile calculator.java. I know that you will ask for the proof. If you need any proof, I am giving a dependency here. What is the dependency? Jar file. So it will go to the jar. Jar means nothing but a zip file, right? It will go to the jar, and then it knows how to find out a particular class, and then it will check the proof and then find it will give you calculator.class. That's how compilation happens if there are dependencies. Clear with this? Any questions you have so far? One second, let me take the charger.
Sir, how will you know that which files are dependent on the main class?
We don't know, developer know. If you are writing this Java code, you know, right? There is that function.
Okay.
Developers know. As I said before, this is not our job. Okay. We don't need, sorry, as a DevOps engineer, we don't know which jar file is required as a dependency. No, we don't know. Developers know all this stuff, which jar file has a particular file and things like that.
So we'll just run ambient install.
Yes, just run it install blindly, that's all. One second, let me charge the battery. Okay. So just remember one line. When we are compiling something in real time, okay, there will be dependencies. One file will be calling another file, right? When developers write the code, they know all these things. Okay. So in order to compile some Java files, we need some dependencies. Dependency means jar file usually. Okay. Without dependency, you cannot compile this. If you don't pass the dependency, what will happen? You'll get the compilation error because it cannot check the proof. So most of the compilation errors in real time we get because of missing dependencies. If developers know, don't find right dependency, you get compilation errors. This is how you manually compile a .java file. But we use Maven, right, for compilation. We don't manually compile each and every .java file like this, correct? What we use? We use Maven. So in Maven, what is the next question now? It is we are using Maven to compile .java files, correct? So when Maven is compiling the code, how you pass this dependencies? You have to pass the dependency, right? If it is a manual comparison, this is how you pass. If it is Maven, if you're using Maven, how do you, find, how do you tell Maven that, okay, this is the dependency, this is the jar file? How do you tell? Yes, where do we configure that? Where we can configure? Smriti, go on mute. That's okay. Okay, tell me, how do you tell Maven, how do you tell Maven that this is the dependency? Where do we configure all build related things?
pom.xml via dependency tag.
Yeah, pom.xml file. So if it is manual compilation, This is how you give. If you're using Maven, then you have to give these dependencies. You have to define those dependencies in pom.xml file. Clear? So okay, see this. So here we have calculator.java. Okay, this is calculator.java. Where do we declare the configurations? Where do we declare the dependency? In pom.xml, right? So here you have to give something like addition.jar. Addition.jar. How it works? You execute maven install. We all know, right? This is your dependency section. The moment you execute maven install, it first, very simple. If it is a manual compilation, this is how you give the dependency. In Maven, put the dependency in the pom.xml file. Simple. How it works? The moment you execute maven install, it first reads pom.xml file. And here, no, correct? It knows that, okay, this guy needs a dependency. This guy needs a dependency. So it'll, you know what it'll do? It will go to something called private repository. Private repository. This is where this is where we store the jar files. Addition.jar files. So you'll be having a lot of jar files here. Where do you store jar files? Addition.jar file or any other jar files, all dependencies in a private repository. Think that there is a computer somewhere. There is a computer somewhere. In the computer, you have some folder or whatever, and then you have some jar files there. Clear? This is where we store dependencies. Who stores the dependencies again? Developers. Assume for now. So what I'm explaining, we first clone the code, then we build the application, we deploy the application. That is our job, right? That's our job. I clone the code first. When I clone the code, I get all this, correct? Including the repository setup will be there. Then I have to build it, correct? That's our job. What is that command we run? Maven install. So what happens when we run maven install? It first reads pom.xml file. There is a dependency declaration here. Okay. So what it will do, it will go to the private repository somewhere in the world. Okay. Assume that your company and then you have submission. Wherever you are executing this maven install, we are executing this maven install in our laptop, right? DevOps laptop. So it will download this particular addition.jar file in our laptop, wherever you're compiling the code, where it will download in .m2 repository. If I am compiling the code in this laptop, okay, it will download the jar file from the private repository to this laptop. So this is where I'm compiling the code, right? In this laptop only I'm compiling the code. I clone the code, I have source code here, and then I'm compiling. So it downloads addition.jar file. You have addition.jar file here. That's what happens. before it enters into compile, test compile, and all the stuff, see how many things are happening there in the backend. Last step, the moment you execute and install, it reads pom.xml file. There is a addition.jar file. Who updates addition.jar file? Who writes that here? Developer. So when developer is writing calculator.java in his laptop, they also modify pom.xml files. They know how to declare their dependencies. That is their job. As DevOps, we don't know how to declare the jar. It's a developer's job. Okay. So developer declared it, right? And in GitHub, you have code and then new pom.xml file. So what we do, we want to build, we clone them. When we clone the code, we get map pom.xml file, Java code and everything. And we execute and install. It will go to the pom.xml file. It will read dependencies. Then it will go to private repository, Maven, connect to the private repository. Then it will download the dependency from private repository to your laptop's .m2 repository. We call this as local repository. What is that? Local repository. Private repository, local repository. Dependencies are downloaded from private repository to local repository. We call it the local because this is in our laptop, wherever we are compiling it. So this is what is happening. Then it goes to compile target. Compile. Now, what happens during compile? It will compile the main code, right? Correct. So it will go here. src main Java group ID calculator.java. It has to compile this. Maven compiles this calculator.java. This has a dependency, right? This requires a dependency, right? And dependency is already downloaded. So Maven will go to the local repository. It will check if the dependency is there or not. So it will, that means Maven internally calls Java compiler only. So Maven calls Java C, right? Java compiler will go to .m2 repository. It will check the proof here. You have the proof and it will generate class file. Simple. If you are compiling the code manually, you give jar file in the command. If you are compiling the code using Maven, you declare the dependencies in pom.xml file. Who declares? Developers. So that's what happens when we execute mvn install. If this is not declared, then we get the compilation error. Our build will say, okay, build failed, and these are the compilation errors. So what do? Do we need to development team? We have the code in Git. We take the code, we build the var file, we deploy the var file, correct? So we are compiling the code using Maven. Assume that, in pom.xml file addition.jar is not there. It will throw the compilation. So what do? We report it to the developer. Developer will again add those missing dependencies in pom.xml file. That's how calculator.java compilation happens. So we declare the dependencies in pom.xml file. Just remember that. Okay. If you had not understood the concept, remember, you know what is dependency. If one Java file is calling the code which is in another .java file, you need to pass that other .java file as a dependency. Actually, .class file. Actually, jar file, because we may have to pass multiple class files. Okay. But in Maven, same jar file we put here, and then we declare in pom.xml file. Maven automatically downloads it from private repository. Private repository is nothing but a mission, okay, where you store jar files. Developer know how to store jar files there. Assume for now. And that's how the compilation happens. We call it a local repository, .m2. This is called as private repository. Clear with this? Any questions here, Sophie? Go ahead if you have any questions.
Sir, let's say like the developer is writing the code for the first time and the dependency is for the first time also. They have written dependency. I mean the function only. So how they will be converting this file into jar for the first time? So initially there won't be it won't be converted into jar file into the private repository, right? So how it should be done? Like, is it done through the Maven or?
They do it using Maven only.
Okay. So,
So
how yeah, yes, yeah.
yeah. So whenever developer writes the code first time, right? They compile the code, right? When they compile the code, they get dot class files and they create the jar file. So the moment jar file is created, once jar file is created, then this addition.jar, for example, it will be uploaded to private repository. Question, Vishnu? Any follow-up question on that? Or it is not clear?
Sir, where the private
Yeah,
repository
it's clear.
where the private repository is located? Will it be in GitHub or in the developer's laptop?
It's not GitHub. It's a separate mission. Think private repository as a separate mission, and then in that mission you have jar files stored. Okay.
Okay.
See this. There is something called central repository also. What's that? Central. You may be having few confusions, I guess. Okay. When I complete the topic, by time I complete the topic, you'll be having, you'll get the clarity. Just wait. If it's blocking, you ask me the question, otherwise note it down somewhere. Even if it's a small confusion, I'll clear it later. Central repository. There is something called central repository also. So 3 repositories. This is not Git repository. Git repository is different. So in these repositories, we are storing the jar files, not source code, not .java files. Okay. So this is a private repository, right? So we have private repository, we have central repository, we have something called local repository. See this? Sometimes developers will be referring open source code. My developer is writing code for for payment gateway. Okay, developer is writing the code for developing payment gateway functionality. So our developer has to read credit card, correct? Use this credit card, for example. So developer will ask, that means when a customer is using Flipkart, for example, there'll be some field, right? Enter credit card number, OTP, CVV, whatever, right? So once user enters, developer reads all that information. For example, credit card number is equal to something, OTP is equal to something, for example, CVV or whatever. CVV is equal to something. And then now developer has to write the code for validating this credit card, correct? Whether the credit card exists or not with that number, whether OTP is correct, CVV is correct, and things like that. We have to validate, right? Without validating credit card, can you place the order? No. So developer has to validate the credit card now. So developer is writing a function, validate. You don't need to understand the code since I know Java bit. I'm writing the code. I'm able to explain the dependency concept to you. If it was another DevOps trainer, he or she may not touch this topic at all. No. And that's fine also. Okay. Because this is not our job. Since I know something, I'm trying to pour my knowledge to you. Okay. Otherwise, usually you take, any trainer, DevOps, they don't touch this topic. They say, it's not our job. Maximum, they just say, they don't even write the code, something like this. They just say, dependency. If you want to compile this, you need to have some jar file and declare the jar file here. Max. So Why I'm mentioning this? Because I'm writing some code, okay, some pseudocode at a very, this is not real code. Okay. So what I'm going to say is, if you are not understanding something, here, don't worry, is what I meant to say. That's the reason I'm taking that example. Okay. See this. Credit card number, OTP, CVV. Then developer is writing the function, validate credit card. And then developer is giving credit card number, like add function, OTP, and then CVV. Okay. Now our developer has to write the code, right? Take the credit card number, OTP, CVV from the user. And our developer has to write the code to connect with the bank database, for example. Check if the credit card exists, if the OTP correct, CVV correct, blah, 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 blah. Lot of code we have to write. But assume that there is a payment gateway software already designed by somebody. There is a payment gateway software designed by somebody already. Say Visa payment gateway, Visa or Razorpay, there are many. So they have developed the software already, correct? This company, third-party company. Can we call it as a third party? Not our company, not our, some third-party company. So they have developed the software already. So when they have software already, why you want to, write the code again, correct? Code reusability. So when somebody already designed something, developed something, why you want to reinvent the things again, correct? First reason. Second reason, you may not have permissions to inquire or connect to the bank database, inquire about the credit card and things like that. You may not be having. So Visa may be having, because they have some special permissions and things like that from Reserve Bank of India or whatever. The central bank, basically, whatever you call it. So we call this as third-party code, or you call it as open source code. What's that? Open source code. It may be free or it may be open source, means usually free, right? If that code which you are using is not free, call it as a third party. Basically, call it as open source. Okay, free, say for example. Somebody in the world, okay, wrote the code for validating the credit card. So our developer is taking, the inputs. Developer is calling validate credit card function. And where is that validate credit card? Who wrote that? Validate credit card. Who wrote this? This guy, somebody. It's a free, say for example. So the moment we execute this is our file, proprietary code, my own code, my code. So validate CC, the moment you execute the code, it will go and call this function. It is passing credit card number, OTP, CVV, and all the things, correct? So credit card number, OTP, CVV. So we are giving all this value here, and there is a code here. They try to connect to the bank database. They have some logic here. Finally, it will say return, right? For example, result. So very simple. Our developer is writing the code for payment gateway functionality. We have to validate the credit card, right? Instead of we writing the code, assume that there is a open source code. Somebody already developed some functionality. So instead of writing the code, we have to save some time, right? So instead of writing the code again, right? So you just call others code, and then this open source code has a logic to perform something, and then it will give you the result, whether it's a correct or whether it's a true or valid or not. So you get the result. Here my developer is writing the logic now. Result. What is the value of this function? If you execute this function, basically it will get something, yes or no, valid or not valid. My developer is writing if result is equal to valid, say for example, valid, then place the order. Else, if the result is invalid, reject. where is the logic for validating credit card? In some other code. In this case, right? In this case, calculator.java is our code. Addition.java is also our code. So this is calling something, there is a logic, you're getting something, correct? So if you want to compile this, you need to have this particular dependency. Same thing here, right? Since we're calling validate CC function, if you want to compile this, you need to have this, correct? You need to have this. This is, say, for example, check cc.java file. Clear? You need to have this, right? So if you want to compile calculator.java, you need to have this. Compiler will ask for the proof. And who wrote this code? Where is this code? This is not our code. That means what? Whoever writes this particular open source code, right? Free code, they would have compiled it, right? And they would have created a jar file, right? cc.jar, say, for example. It is their responsibility. Whoever writes this particular open source, they wrote some code, right? And they compiled the code. They have the jar files. So anybody in the world can take the jar file. So if I want to compile my code, cc.java, what do? I will download this cc.jar as a dependency. So if you go to their website, for example, you will get this jar file. Likewise, there are a lot of open source softwares. Usually, the students, like, a final year, graduates, right, or students who are learning something, right? If they want to, learn something practically, they go and then work free for those open source softwares. And there'll be some team, right? They give the permissions. If see you also, Arjun, you want to learn Java today, there are a lot of open source projects, right? You can go and then ask that project committee for team. They will give you access. You can modify the code, you can do whatever. So that's how the open source softwares get the contribution from whole world. It's like you're helping others and then you are also getting benefit out of it, a good learning, right? And are some technology enthusiasts, people like you and me, when they have some freedom, they contribute to open source, and that's a free, and then anybody in the world can use it. Open source. So two things. We may be having dependency within our code. This is our code, this is our code. So addition.jar file is our file only. Right? In some cases, we'll be having dependencies on open source code. So if you want to compile our code, we need to have that code's jar file, correct? Whatever open source we are using, we need to have that jar file. And it is open source free, right? So these kind of open source dependencies will be in central repository, cc.jar. There are a lot of jar files here. And whole world can download the jar files. Whole world can download the dependencies from central repository. Anybody can connect to central repository, download the jar files. Clear? Now you understand why we call it a private repository. It is our own repository. Addition.jar we don't give to others, because addition.jar is our proprietary code. This is our software code. We should not give our code to others, right? At the same time, there is some open source, and open source jar files are dependencies are in central repository. Assume that developer has another .java file here. Validate our credit card.java. The moment developer writes credit card.java, this one, developer know what code he or she is calling, correct? Developer know what is the jar file. So what do? They know the dependency. So they go and then declare the dependency in where? pom.xml file. How execution works now? The moment you execute and install, it reads pom.xml file. There are two dependencies, addition.jar, cc.jar. Maven, remember this. Maven by default goes to central repository. What's the default connection? Maven by default goes to central repository. It will check addition.jar is not there. Okay. cc.jar, it is there. What it will do? It will download the dependency in our local repository. cc.jar is downloaded. So once it checks the central repository, then it goes to private repository. Okay. It reads pom.xml file and it downloads the dependencies either from the central repository or private repository. By default, it goes to the central repository. If it is not there, then it will go to private repository. And from private repository, in our case, we get addition.jar. cc.jar comes from the central. Okay. Addition.jar is downloaded from .m2. See, that's what happens when you execute and install. So once all dependencies are downloaded in your laptop, in your local repository, then it goes to compile. Okay. Calculator.java, there is a dependency, it refers it. cc.java compilation, there is a reference. That's how Maven compiles these two .java files. So overall, okay, very simple. You may require multiple .jar files. So all jar files we declare in pom.xml file, and jar files will be downloaded either from the private repository or central repository. Maven by default connects to central repository first, then it will go to private repository. Anybody in the world can access central repository. Okay. Now you may be having a question. How Maven knows where is this private repository? Correct. By default, it will go to central repository. Maven knows where is the central repository. Maven is a software, right? It knows how to connect to the central repository and it downloads code. What if we want to, what if we want to connect Maven to the private repository? Okay. So in pom.xml file, somewhere you'll be having this. You'll be having this private repository URL. Okay. So since you have configured this private repository URL in pom.xml file, it knows how to connect to that repository. How do you configure private repository? That's not in the list. Okay. We are not discussing that topic. Why? Because mostly it's a one-time job. When you join in real time, people would have configured private repository already. First thing. Second thing, even if you have to configure, very rarely, assume, in my experience, I would have set up private repository maybe 1 or 2 times, not more than that. Even if at all you have to, set up, you will be able to do it. Don't worry, it's a simple thing. So I'm not discussing how you set up private repository. First thing. Let's spend the same, time, energy for discussing other important things which helps you. Leave it on me. 99% you will not struggle just because you don't know how to set up the private repository. Don't worry, it will be there. How do you set up the private repository? Just for your information, there is a tool called Nexus. What is that? Nexus. Nexus is a tool. So using the Nexus tool, you can set up the repository. It is a computer. Using Git, you create the repository, correct? Inside the Git, you have the source code. This is your computer. Using this Nexus tool, you can create the repository. Nexus, using Nexus tool, you can create private repository. Using Git tool, you can create source code repositories. So Git is for storing the source code. That means .java files, your application code. Whereas private repositories, central repositories, we call them as binary repositories. You can call them as the binary repositories because we know the binaries, jar files. Okay. How many types of binary repositories we have? Central repository, that's one binary repository. How many types of binary repositories you have? Central repository, that's where we have the free open source software jar files. private repository. That's where we store our own jar files, and then local repository. So jar files dependencies will be stored, will be downloaded either from the central or private into local. So we have three types of binary repositories. Binary repositories are to store jar files, whereas Git repository is for source code. Remember. And how do you create a binary repository? Say you want to create private repository. How do you create it? Using Nexus is the tool. Nexus is like a Git. Git is for creating that repository. Nexus is for creating this repository. And how do you create private repository in Nexus? That's out of syllabus, not required. Leave it. Clear about the dependencies? Any questions you have so far?
The central repository is also created by Nexus.
Central repository by Nexus. I think so. Central repository also is created by Nexus only. Let me check that.
Or will it be both, like combination of both?
This is your Maven central repository. Nexus is open source. They would have created maybe using Nexus only. Maven Central Repository is not built by Nexus tool. Maven Central Repository is a repository maintained by Sonatype, and it serves as a default repository for Maven. So it is not built by Nexus. It is built by a company called Sonatype. They have their own mechanism. See, that's the reason it says Sonatype Central Repository here. Okay. Right. You want me to summarize the topic with important topics? Still, the topic is not complete. Let me just make it clear, okay? Whatever we discussed so far. So our developers write the code in multiple .java files. To compile one .java file, we need another .java file because compiler checks for the proof. So instead of giving .java .class, we give the jar file. So you may be having multiple class files here. With the manual compilation, we just say calculator.java, Java C, calculator.java. It will go to this jar file. It knows how to check the class file, and then it will give you .class file, calculator.class file. That's how you manually compile the dependencies. In case of Maven, we declare the dependency. We declare the dependencies in pom.xml file, right? And the dependency can be within our code, or dependency can be from third-party code. So this is our jar file. This is third-party jar file. So why third-party or open source jar files come in the picture? Our developers, right? When our developers develop the software, to develop our software, they use other softwares. See, to develop our software, we are using somebody else's software, right? So today, these days, you have a lot of open source projects. If you are developing some AI product, or you are developing something, right? Some product or application, you don't have to write the code from scratch. There are a lot of open source resources. So you just should know how to use the open source. That's what that's what our developer is leveraging. So instead of writing the code, developer is going there, calling the function, and then getting the results. So if you have to write this, it may take months for you, and it's not about writing the code one time, right? So to maintain it, bug fixes, you need to develop, add new features, and a lot of things. So to compile our file, we may need third-party or open source code. So whoever writes this Java file, they build the class file, they build the jar file. So they store the jar file in central repository. Okay, so you have open source related jar files in central repository. Since we cannot share our code to the world, we store our code in private repository. So Maven connects to the central repository first, downloads the dependencies. If it is a private, if it is not available there, you'll go to private repository, download. So dependencies will be downloaded either from the Maven or either from the central repository or private repository to local repository. And then it goes to compile, and then it compiles. Since there is a dependencies already downloaded in our laptop, what happens? Compilation happens. The developer, whoever wrote the Java code, they know how to declare the dependency. It is their job to declare the dependency. If they don't declare the dependency in form.single file, since dependency is required at the time of compilation, it will throw the compilation error if it is not declared. 1 second. Okay. What was I explaining? Okay, so it's a developer's job. So they know what dependencies are required, and then they declare it. Okay, our job is to just run Maven install. Okay, if there are any compilation errors, report it to the developer. Developers add the dependencies, and then they that's how you solve your compilation errors, and it's a completely developer's job. So if you know the topic, it's good. It's also good to know concept. You can very easily interact with your development teams in real time. You can understand when they say, okay, there is some compilation error, I'll have to add the dependency. You should not ask what is dependency to them, right? Correct. Now you know that what is dependency. So good to know concept. If you remember these points, enough. So 3 kinds of binary repositories we have: central repository, private repository, local repository. So these are called binary repositories because we store binaries there. GitHub is for source code. Clear with that? Any questions you have so far?
So MVN install will only help to create a from Java file to class file only, right?
Yeah. It will compile the code and it will also create the jar or var file.
Okay, same MVN install will be like creating a jar and war file as well.
Yeah. It compiles the code, right? Our
Okay.
code. And then you get class file, correct?
Yes.
Once you get to hundreds of class file, then we have to create the jar file. Again, we get multiple jar files. For login one jar file, for search one jar file, and so on. Again, we have to combine all the jar files, and finally we have to create the var file. So compile, test compile, generates the reports, test. Then there is a target here called package, right? So this is where it will compile the code. Compilation happens here. And during package phase, it will take all the class files, create the jar files. Again, it will take all the jar files, and then it will place all the jar files in a var file. So that's what happens. During
Okay,
install,
so
we create all this happens.
okay, at once only it is doing all the tasks, right?
Yes. But
Okay.
every day we'll be having new code. So every day we'll be getting the new code. Every day we'll have to compile the code.
Okay. Okay.
You want me to draw the diagram again? One second. So, see this, everybody. I was expecting some questions where you make me draw this diagram, but maybe things are very clear to you. So, this is your source code repository, correct? We first clone the code. Our job is, developer's job is committing new code every day, every minute, every second. Every day we'll be getting the new code. And they have to test, right? Tester is waiting here. So tester, for tester, he or she need an environment, right? Flipkart-sit.com, system integration testing.com. So as a DevOps engineer, the developers that is writing the code is their job. As a DevOps engineer, we take the code. What is our responsibility? You have to take the code every day, every minute. We have to compile using Maven install. And then we'll get the class files, jar files, and then finally we create the var file. And then we have to deploy the var file into Tomcat server, correct? Tomcat. Then only tester can connect and then test the application. So this is where we execute Maven install, right? So first time, assume that it's a 9 a.m. morning. There is some new code. We clone the code. We execute Maven install. Tell me what will happen when you execute Maven install. We first clone the code, then we execute Maven install. So it compiles main code, testing code. So it compiles the main code, testing code, right? Compile, test, compile, generate the reports. There is a package step there, right? So all that happens. So compile the main code, testing code, generate the reports, then it will get jar or var file. That's a final output. You take the var file and then deploy it. Done. I can say it's a 5 p.m. for example. Again, we take the code. Now there is some new code here, right? Again, we execute Maven install. What will happen? Again, it will compile the new code, testing code, and things like that. So assume that during 9 a.m. you have executed Maven install. What it will do? It will download the jar files in your laptop .m2 directory, right? Either from the central repository or private repository. This is your .m2. Yep. Okay. .m2. So it downloads the dependencies only once. Assume that 5 p.m. if it requires same dependencies, if the dependency is already present, it will not download. Otherwise, it will download again. So again, you compile the new code. Again, you create fresh jar files, which has the new code, and var file, which has the new code. Again, you deploy it. So you have some changes. Again, these people take the change. So the process is continuous. Every day we will be compiling. Every day we'll be deploying the new code. It's not one-time task, but every day we'll be generating new jar files, which contains new code because there'll be change in the code. Ashish?
Yeah, understood. And suppose if like I know maybe it is not included, but suppose someone is using ANT for building a war file or something like, so whether ANT uses like manual way or it also has the same way that like how Maven is done.
That's a good question. So ANT doesn't have this repository concept. You have to store the jar files in some folder, for example, somewhere in a mission, and then you have to give that path. So in ANT, you don't have this repository feature. That's the biggest advantage of one of the biggest advantages of Maven over ANT.
Okay.
see this. And how developers modify the code, you know, right? So folder structure, you know, Flipkart, src, main, test, blah, blah, some Java code, And there is a pom.xml file, correct? Pom.xml file. Harry downloads the project from Git. Flipkart, src, main, test, developer gets some test, main code and then testing code. Along with src, there is a pom.xml file. Okay. Assume that developer writes calculator.java here. He writes the code and he commits the code. So assume that for calculator.java, you need some dependencies, addition.jar file. So they know, they go and add pom.xml file. So there is a new .java file here and pom.xml file, there is a dependency also declared. So when we clone the code, we get the same thing, right? Flipkart, src, main, test, some Java code, and then here pom.xml file. So there is a calculator.java here, and developer has written the dependency also here. So when we execute maven install compilation, since it will download the dependencies and then it will compile the code. Finally, it will give you the var file. That's how developers write the code. That's how the code plus your dependency changes in pom.xml file comes in Git. That's how we take the code and we build it. For example, there is no dependency. What do? We report it to the developer will fix it. I'll give you a classic example. So there was a bug in the system. This is your production environment, say for example. Okay, production environment. There is a bug. So what developer has done? A developer modified some Java code. Flipkart src main somewhere, some Java code developer modified. Yes. Developer modified the code. Developer needs a dependency. Dependency also declared in pom.xml file. This is developer's laptop. And then developer thinks that Java is, Java code is pushed, and then pom.xml file changes also, ea.jar is also pushed to the GitHub. Then comes our DevOps engineer, a junior DevOps engineer, Assume this happened in my team. So this guy just typed maven install command. There is a compilation error. DevOps engineer reports that error to the developer. Okay. Developer says, I wrote the code, yes, right? And I have added the dependency in my laptop. I executed maven install command, and everything is working perfectly fine in my mission. So you are getting the compilation error in your mission. You check it. See the thing. Developer was a little harsh. DevOps in this says, we don't understand the compilation error. You only have to help me. You only have to tell us. Developer says, you come to my desktop, right? You come to my workstation. I can show you everything working fine in my mission. Something is not working in your laptop, in your mission, you fix it. This DevOps engineer calls me. Nagesh, developer is very harsh. There is some compilation error. We have to fix that error. We have to generate the package. We have to push it the code. There is some serious issue in the production. So this guy calls me, Nagesh, developer is very harsh. What should I do? I said, I'm on the way to office. Wait for 5 minutes. Then I go there and then I check. Since I'm in the system for a long time, I know, I can guess that that's a missing dependency. That's a dependency issue because dependency issue. I pinged this developer, junior developer, probably. Yep. So I said, there's a compilation error. No, you have to fix. I said, same thing. It is working, everything fine in my mission, Nagesh. Then I asked him, can you send me your pom.xml file that you have in your mission? He sends. I compared this pom.xml file with the pom.xml file that we have. Flipkart, src, main, test, pom.xml file. This is where we execute maven install, right? So when I compared, I see that there are some extra changes in his pom.xml file. Then I ping him saying, okay, are you sure that you pushed your pom.xml file to GitHub? Developer says, yes, I modified my code. I have my new code in the GitHub. I have my pom.xml file changes also. I said, no. For some reason, due to network issue or developer forgot or something like that, there is a code, new code, but that his pom.xml files are not, uploaded, are not pushed to the GitHub. What we have done, we take the code from GitHub, right? I took the code. So there is a calculator.java, but pom.xml file is old. Whatever we have in the GitHub, we take it, right? So there is a new code, but dependency is not. What happens? We get the compilation error. So I explain the same thing to the developer, saying, this is what probably happened. So go and then push the pom.xml file to GitHub. What this guy has done? Uploads new pom.xml file. We take new pom.xml file. Now there is a code, there is a dependency. Problem is solved. In these kind of scenarios, right? This topic will be very, 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 very helpful for you. That is the reason I have taken this concept. If you know this concept, you can work with development teams very easily. Okay. So as I said, selecting the topic is mostly the trainer's choice, correct? And I have faced all these things in real time. So that's the reason I feel, if you know, you can comfortably work in real time. See the same thing in another use case, right? So there is a developer. Okay. Developer, same mistake. Okay. There is some code. He forgets to, write the dependency in the pom.xml file, or the jar file name is wrong. Some issue is there. So we have the code. Okay. Either jar file is not declared or the wrong one is declared. Something, there is some issue. I take the code, I compile the code, I get the error. I report it to the developer. I report it to the developer. Now, developer says, again, serious issue in the production. Developer says, Nagesh, I compiled everything in my laptop. Okay, things were working fine. So I just stepped out for a lunch. So I cannot look into it. I need 2 hours of time. Even if I start, it'll take 2 hours. You cannot wait for 2 hours because your management team is behind you, right? Why DevOps engineer? Why the code is not pushed? Why the bug fix is not pushed to the production? You say there is a compilation error. Bal is not in my code, right? It is in somebody else's code. You go in and check. No, that's not a ownership, right? What is our job? Our job is to make sure that deployment happen, coordinating with all other teams. That's our job. We have to take that ownership no matter what. You cannot just say, okay, this is not my issue. If I don't get the response, I cannot, this is not solved. You cannot say that, right? So you talk to the developer saying, okay, this is what is happening. I didn't get your response. So why? So 2 hours. Now we tell. In these kind of scenarios, what do? You can ask developer. Okay, I know the concept. So you just tell me what you need to, what is the issue? Developer says, looks like some addition.jar dependency is missing. Can you open the pom.xml file and check? Straight away, you go here. I need another 10 minutes because if I stop the class now, then tomorrow again, we have to start from scratch. So developer says, okay. You ask developer saying, okay, it's a dependency issue, Now you are not asking your developer, okay, what is dependency and all, right? See, you understand developer's logic now. You understand the concept now. One second. So you're not asking developer, right? What is dependency and things like that, right? Things are very easy for you now. You ask developer, you tell me, since you're out, you tell me what needs to modify, right? What dependencies need to be added. Okay, I can add it. Clear? Now, see here, this is where we add the dependencies. If I explain this, code snippet, you only can add the dependencies. I'll tell you how you add the dependencies. Since we are discussing this use case, see this. Can we just go on and say addition.jar in format? No, right? We represent the information in XML format, correct? So how do you declare a dependency? That's a question now, right? Correct. That's a question. With this, topic is over. So how you declare the dependencies? Very simple. Dependencies have GAV parameters. Dependencies have GAV parameters. So dependencies, what's that? Dependencies plural. Dependencies start tag, dependencies end tag. You all know this? Start tag, end tag. In the plural dependencies, because you may require multiple dependencies, correct? Addition.jar, credit card.jar, no, multiple jar files, right? So for one dependency, you have to write this code. This is for one dependency. This is for one dependency. So dependency start, dependencies end. This is for one dependency. Dependency singular, singular end. And dependency has its what? GAV parameters. That's how dependencies are identified. So you have some jar file with GAV, right? The moment MU install comes here, it will check GAV parameters of this particular jar file. So it will go to the central repository using the GAV parameters only. It will identify the jar here. It will download. Or it will go to the private repository. You have given the GAV parameter of that particular jar file, right? So it will go to the private repository using the GAV. It will identify the jar and then it will download it. So jar files are identified using its group ID, artifact ID, version number. How you know group ID, artifact ID, version number of a particular jar? Developers know, like how we are learning our stuff. They know how to do their stuff. Okay, they learn all the stuff. So see this dependency start, dependency end. Group ID, artifact ID, version number. Group ID start, group ID end, group ID, artifact ID start, artifact ID end, version start, version end. And who gives all this information? Developer, they know. Now you come here. Developer comes and says, so you ask developer, there is some issue, right? Tell me, right? You can directly say, okay, developer says it's a missing dependency issue. You are not asking developer what is dependency. Now you understood that, okay? Some jar file is missing. You are asking developer, okay? See, this happens in real time. So I've faced all these things in my experience. Then what happens? You ask developer, okay, tell me the GAV, dependency details. I will go and then modify pond.xml file on your behalf, because it is in a critical situation, correct? Developer says, thanks for your help. So what do? Set no number. And you just copy this chunk. This is for one dependency, right? Is it difficult to do all this? Okay. So dependency start. This is for one dependency. This is for another dependency. Okay. So here I come. I erase this. Okay. Now I'm asking my developer. Okay, developer, I'll add the dependency. Tell me the dependency's group ID. He'll say servlet. Tell me the dependencies, artifact ID, servlet only. Tell me the version of that dependency, 3.5. Done. Problem is solved. Clear? Now, if you don't know the concept, what happens? First of all, you don't know the start tag, end tag. First of all, you don't know jar file will have has its GAV parameters. You don't know, right, how to declare the dependencies and things like that. So developer has to dictate open bracket, close bracket, make sure that you have this, you have this, you have this. See the struggle that you go through. So you modify the dependency and then compilation is done. You compile the code, create the var, then deploy, problem is solved. Guess what happens? once the developer comes back, to office from lunch, he'll not go to his workstation. He'll come directly to you. Thank you, DevOps engineer. That's my responsibility. You saved my life today. Otherwise, things get escalated, right? And this guy says, our DevOps engineer goes beyond his responsibilities and then helps the team. This guy is a core DevOps engineer. Two DevOps engineers. They know only their stuff. There's a compilation error, blindly to throw that error on developer's face. One developer, DevOps. Other DevOps understands things at a core level and then solves the problems. See the difference. That's where you are identified in your floor, salaries, and a lot of benefits. Correct. So this is where you mostly struggle in real time. I know this. That's the reason I've included this topic. Now, you know what is dependency, where we store the dependencies, how Maven compiles the code, downloading these dependencies, and you also know how we declare the dependencies. I don't ask you to usually revise my class recordings, but if you still have any confusions, suggest you to go and then revise the recordings topics. Clear with this?
I'm facing similar kind of problem. Actually, I made a simple page for login to practice DevOps. It runs very nicely in Eclipse when I compile it in there. But while in running ambient install, it throws some errors.
That login.java is your code. You only wrote that.
Yes, sir.
Check if
Well,
you have downloaded the import statement, like you say import what is that, java.util.package.
So, but it works very fine in there in Eclipse.
If you are importing any such things, Java util and things like that, you need to have that suitable jar in the
Sure, I checked everything, but again, it's showing something release version 22 not supported like this. At last, it shows.
Lokik. First of all, you have to come out of that Eclipse. That's for the developers. Don't practice these things there.
No, sir, actually,
If you have, no, one second. If you do the things in Eclipse, no. So you cannot learn the things. But I don't know what's your goal. Whether you want to continue your career in, if you want to concentrate on development, you can do. But otherwise, Eclipse you should not touch.
no, sir. Actually, for practicing DevOps, I made this file.
Then don't compare it in Eclipse. Just close the Eclipse. Compile it manually. Java, C, login.java, like how I did in my class, in our class. Okay. See, what is it you're doing? You have written some .java file. You want to compile it, correct? Basic .java file. Compile it in the command line. Java C, login.java.
No. Actually, I'm trying.
What do you want to do? Tell me.
Ambient install command. I was trying to means experiment with ambient install command actually.
Where you are executing that in Eclipse?
No. In Linux.
In Linux, if you are getting the error, you have to fix it. Show me. But you're not building in Eclipse. We should not do that. And in fact, we don't build the application in Eclipse in real time as a DevOps.
For means for sample purpose, I need some raw files to convert in this ambient. So I made that.
I'll check it. I'll check it. Before that, maybe few people may want to, drop off from the class. I'll take your. I'll check what the issue. Any other questions you have, guys? Otherwise, this topic is complete. Go through the recordings. If you still have the questions, okay, I'll take in tomorrow's class. Okay, share your screen.
Is it visible, sir?
Yeah, I see it. Compilation. Release version 22, not supported. This is different. What is it? Release version 22. Compiling. Show me the Java code. Have you written many .java files or
No,
only?
one for practicing purpose only.
src main Java. Good. I'm happy that you are experimenting with something. Public class -b extends HTTP servlet. You wrote this code?
Yes, sir.
I have to go back 10 years. I have to go 10 years back now to understand your code. Public string add blah 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 blah. So you're using servlets. Do you have all these dependencies? Binaries of
Yes.
servlet. You have written
Yes.
this in your Eclipse.
Yes, sir. It runs fine in there, but when I run ambient install in here, then it fails like this.
So now you became a developer. This is not a DevOps topic, it's a developer thing. So in Eclipse, you would have downloaded the dependencies configured, right? Okay. So you have to identify those things and bring those jar files in your private repository. Then only Maven downloads the jar files. Or if you know all those binaries, put them under .m2 repository. End of the day, you should have those dependencies in .m2, right? So go to .m2 repository, and you have to follow that structure also. .m2 repository. Again, you should know the dependencies GAV parameters. .m2 repository, group ID, artifact ID, version number. There only you have to copy the jar file. So doing all those things manually is very, very difficult now. It's not a small thing. Okay, let me ask you to open pom.xml file. So I know you know Java, and that's the reason you're practicing all this. This is not required because you can. This is good. Experimentation is good, but this is all the developer's job, right? So why you are doing and then wasting your time? So just create a simple hello world.java. Can I tell you one more thing here? And the Java file should start with the caps, right?
Yes, sir.
Make that change first. That's a basic mistake. And see again. The moment I'm talking more about Java, my daughter has come and then sitting beside me today. Dad, you are discussing more about Java today. What's happening there?
Actually, I'm not trying to learn Java, but I'm trying to learn Eclipse. This Maven and DevOps things. So I haven't got any source base to. So I made this.
You're a working professional. You're currently working, or you're a student, or what you're doing?
I'm working as a teacher.
You're working as a lecturer
Yes, sir.
in India, somewhere abroad.
No, in India. I'm from Assam.
Okay. What subjects you teach?
Computer science.
Okay.
So this is my pom.xml file.
Open it in the Vim editor. I'll spend only another 5 minutes. If we cannot, then you just leave it, okay? Or you explore, because that's a developer job. I don't want to touch it. Change that Java file name first to caps. .java file should be in caps, right? Not here. .java file, src main. Try to use tab src main Java. Just type JA and then use tab. It'll automatically fill it. Java. Okay. Com. My first. Whatever you have given. I think it's different. Move MV. DASHP, capital D. .java. You're renaming the file. Open the Java file in Vim editor. Public class capital D right there. Public class capital D. See, you have you're declared as a com final cut, right? So again, the group ID artifact group ID also should be the same path. -B. You are importing HTTP servlet request response both. Okay. Save and quit. Execute and install. // cd space // You can give multiple //. Okay, that's better. One second. Don't type it. Go back. Delete. Stop there. No. Just type MY capital P. MY capital P. Stop. Press tab. Logic.
Okay.
Okay. Try to use tab. Just that habit is good.
So, sir, if this type of problems we face, then we can say it's from developer side. No?
Yes, exactly. These are all the developer issues. They only fix it.
Okay.
Now it says error. Please, sorry, release version 22 not supported. What is that release version 22? Is that mentioned somewhere in?
I think it's the Java version. I think. I think it's the Java version, JDK version.
Java version. Because you have written some complicated code there. So servlets and all those things, right? So you have to have all those. It's 11 only. Open pom.xml file and see what is the 22 it is referring to. One second. Compile. My login project. Pattern. Compiling. Open pom.xml in Vim editor. See, where is that 22? The release 22 you have given, right? What is that? One second. Maven compiler plugin. Okay. There 22 is there no release. Maven compiler plugin. Plugins version. Come down. 3.8.1. It says that
This one.
22 is not supported. Release is not supported. That one. Wait a sec. This code is generated by Eclipse, correct?
Yes, sir.
This is the problem. So again, Eclipse generated this pom.sql file in its own way, right? So that works in Eclipse. So whatever it requests for it, so it downloads. But we are not using Eclipse now, right? We are using Maven. So Maven is not understanding this release. Your Eclipse is understanding that.
Yes.
So basically, Maven compiler plugin, you are changing some, the way Maven compiles, the way Eclipse compiles internally is different. So this is Eclipse way of compilation. So Eclipse has some customized, some custom compilation things. So that is not working with Maven. Okay, copy that error and then check in Google. Probably we have to give a different release number here. Go back to the console. Copy that line. Yeah. Error release version. Before that, just type Maven error. Can you open browser?
Yes. Yes, sir.
I don't see the
Is it-
browser. Share your complete screen. I think you have shared only one screen. Share complete desktop. Stop and share it. Yeah.
Is it visible now, sir?
Yeah. 1 second. See the like Eclipse, there is a IntelliJ idea. That's also like Eclipse. So that's related to that. Scroll down. Scroll down. Maven compiler plugin. Click on that. Down. So which Java version you are using in your Eclipse?
Earlier it was 21 or 22 something, but now I tried to convert it to 11.
Your Eclipse, wherever that is working fine, what Java version you have currently there?
Now I have installed 11, Java 11, JDK 11. But
Eclipse is also using JDK 11 only.
yes, sir. But earlier it was, I think, 22 or 20.
So there is a issue with this issue maybe with the Java version mismatch also. Okay, so come down 1 second. Scroll down. Down 1 second. Maven compatible. Can you show me that error in the console? I cannot see. T2 not supported. Open pom.xml file in Vim editor. It is Maven compiler plugin. Okay.
Okay.
Now come out. Browser. Scroll down a bit. One second. See, with the 17, it is 17. With the 21 Java, it should be 17. With 17 Java, it should be 21. So scroll down. Down. Make it 20 blindly, let's see. You understood, right? The point. So your Java, Maven is developed in Java, correct? So to execute Maven, we need a Java. So whatever Java version you have, that is not supporting this 22. Okay, so make it 21, let's see. So you have to find out, if you do some research, no, what version of Java you're using, what, very simple logic. Maven compiler plugin 21 version you're using. This Maven compiler plugin 21, will it work for 11? Will it work for 17? Will it work for 21? You just find out somewhere. That will solve the problem. You have to select the suitable one. Your Eclipse, no, it is very intelligent. So it has selected the suitable one. It is working in Eclipse, but here it is not working.
Actually, I'm unable to find whose fault is this, from developer side or from DevOps.
Developer. This is a developer thing only. Purely
Okay.
developer. Make it 17. I'm just guessing and changing, but you have to find out the real one. Somewhere, it will be there. Or do one thing. In Eclipse, whatever Java you have, same Java, you give it to Maven and then see. Save and quit, install. It's a purely developer thing. Since I know development a bit, okay, so I'm able to identify. But otherwise, other people, it's not our job.
Wait,
Open public. One second. Just comment that complete section, plugins. You understand, right? It is generated by Eclipse. Maybe for Maven it is not required. No, that plugin, not the plural one, only from the plugin. Comment it. No, that's not comment in XML. It's a left angular bracket. Search in Google, comment in XML. It's a exclamatory hyphen this. Comment in XML. Multi-line comment in XML. Others you can quit. Your wish. Share your screen if you are okay. We cannot see your screen. I know, I got it. That's one. Exclamatory hyphen, then hyphen, yes. Are you referred by Swapnil here? Okay.
No, Pranamika, do you know Pranamika, sir?
Pranamika, okay.
Worked there earlier.
Because I was having another student called Swapnil. He was also a professor. He was my student. So I thought, since you said you are a professor, then I thought. So this lady Pranamika, right?
Yes,
She was colleague or
she is my colleague. Now she is working in same
she got the
college.
job? She got the job.
Yes, sir.
She's working in DevOps now.
No. I think she was from commerce background, and
Mhm.
she worked in Bangalore for I think 2 years or something. Worked in Bangalore.
No, she got placement in DevOps, or
No.
she's still struggling with job.
Yes, sir. She called from from your institute. Someone she knows your institute.
Ask her to call me once tomorrow.
Yes, sir.
Ask her to call me once tomorrow.
Okay, sir.
I'll
Sure.
just find out, why she didn't get the job or what is the issue. Okay,
No,
make
she was
the
she was
Hmm?
working there, but for some family issues, she came to Assam again.
No. Okay, I just wanted to find out. She was my student, whether she got job in DevOps or not.
No. She was not a student of DevOps.
Got it. Then I don't need the call. I thought she is my student.
No.
Leave
I think,
it. Okay, leave it. Not required. Comment it.
yes, is it okay, sir?
I don't see the XML. I don't see the. Now I can see. Perfect. Save and quit. So basically, you should not, use Eclipse generated form.xml file here. You have to write. Okay. So remove that complete thing. Try to write if you really want to practice that. Or you can use that as a reference and then do something.
Sir, if it is from the developer side, then it's okay, sir. I thought it's from my side. So if I will get some raw files from raw projects, then I will try on that earlier build projects.
See this. That issue is resolved now. Okay. Now there is one more issue. Source option 5 is no longer supported. Use 6 or later. Target 1.5, blah, blah, blah. Things. If you search this error in Google, okay, you will get one code snippet again, like this.
Okay.
Can you open our pom.xml file once? Go up. Down. Stop your screen, Logic. Stop your screen. You see this line? Logic. Properties. Start properties and put 1.8, 1.8. If you write this code, then that error will be fixed.
Okay.
It is there in our Flipkart code. We have the Flipkart project, our project. So take the Flipkart or just search that in Google. Put that. Do you have our Flipkart clone copy?
Yes, sir.
Can you copy paste that properties to properties? Paste it there. And also, can you share the screen?
Yes. Is it visible, sir?
Yeah, properties. Copy those 4 lines. So as I said, even though you get some raw files, right? So whoever gives those raw files to developers, those people have to make sure that it is build up the code, build is working fine. Go to your project and then add it. Go up. You can add it. Go up. Go up. After GUI parameters, you can add it. Give an empty line about that, just for the more clarity. Enter. Save and quit. You may install. Okay,
Oh, it's
that error is fixed now. Okay.
okay.
Now you're getting one more error. Scroll up a bit. Up, up. Oh, stop. See, earlier you were getting issue in test compile, correct?
Yes,
Now
sir.
you're able to compile that file. Now it is going to test compile. In test compile, it says there's a compilation error in which file? -b test.java.
Yes,
You
sir.
see here, 11th line. One second. Go. Just highlight it for me. So -b test.java cannot find symbol -b. Okay.
Yes.
Tell me why.
We changed it to capital letter, I think.
Java file, Java code, Java file, .java file always should start with capital D, caps. First letter should be caps always. That's error. Change it to caps, again type, again compile, and keep solving the issues. Okay, this is a new issue.
Okay, sir.
Got it, okay. So other issues are now the file name should be in caps. That's again development rule it is, correct?
Sir, can I get some sample files to practice in this in daytime?
I don't have
Yes,
sample
fine.
code. Okay. Anyway, you're doing it for me. Do it and then hand it over to me. I'll give it to others.
Okay.
Since you are giving me punishment from last half an hour, I have to give some punishment back to you. Correct?
Sorry, sir, if I have hurt you, sir.
Make this workable. I don't have sample code.
Uh,
Oh, I was just joking. Okay. Okay. Fix that issue. Make it capital D. That error will go away. And again, these are all the coding issues. Try to solve them.
Okay.
Appreciate you, Lokik, doing something, good. Keep
Thank you.
R&D. That's what. That is you're trying to explore things from the development way also, because you said you know a bit of Java already, right? And you have written servlets and the stuff.
Yes, sir.
Means you know Java. J2E you have learned.
Yes, sir.
Okay.
In college time, I had practiced this. I have done MSc sir. That time I had practiced, but I forgot all this. But now for practicing purpose, I'm again means trying this.
Good, good, good. Appreciate it. Okay, Lokesh.
Okay, sir.
Okay, we still have 7 people in the meeting. Vishnu, Smriti, Sandhya, Manjunath, Dinesh. Thank you, everybody, for staying. You were curious to know how developer issues look like?
Yes, sir.
Dinesh, Manjunath, Smriti.
Yes, sir.
Yes, sir.
Yes,
So that's how we work. So this is how you are working. Laukik was playing a DevOps role. I was playing a bit of a developer role. Okay. And if both know, I mean, see, like, the dependency concept now, right? Same thing, same kind of things happen there also. If you want to add, any dependencies there in XML format. So this is a different issue, developer issues. So since we both know, like, we were playing, dual roles, sometimes DevOps, sometimes developer, and things like that. So this is how it works in real time. Nothing else. The classic real-time example where things go wrong, and then how we work with the developers. Okay. Fine. Thank you, everybody. Good night.
Thank you, sir. Good night.
thank you, sir.
Good
Good
night,
night.
sir.